My name is Danijela, and I, besides working for Texas Instruments as a trainer, I'm also an education consultant at the Mathematical Association of Victoria. And today's webinar is going to be on Univariate Data, but also there'll be a part on Bivariate Data towards the end. Part one, we'll talk about optimal TI-Nspire settings for further maths. We'll create some histograms and we'll consider and interpret log scales. Following that, we're going to produce some summary statistics, so the 5-figure summary for univariate data, and I'll show you how to create a useful notes page. And in part 3, we're going to look at some bivariate data that is categorical. The first things first, we're going to look at how to set up your TI-Nspire CAS so that it's kind of set up for a further maths exam. So here I am on home screen, and I'm going to select number 5, settings. And then I'm going to select number 2, document settings. The first thing here is display digits, and you can see the default is on float 6. So what that means is that the calculator automatically has set a float 6, which is 6 digits of precision. That means when you're calculating anything, the most number of digits that it will be as given as an output will be 6. If according to the kind of context you're in, and we'll see how that's applied later on. The float is really useful as well when you're dealing with significant figures, and I'll show you an example of that later. Now in the angle, you want to, as you can see here in the drop-down menu, there's 3 options for what unit of angle you want to measure in. For maths, it's best if you stick with degrees. That's especially relevant if you're doing the trigonometry section. Now, another important point I wanted to mention here is the calculation mode. For further maths, the best calculation mode will be approximate. Now, you have to keep in mind that all these display settings here are the ones that are optimal for the mathematics. If you're doing further maths and maths methods, you'll have to change the settings depending on the context you're in, on what environment you're in. So for maths methods, sometimes it might be more appropriate to do exact as shown. And also, likewise, you might need your radian to be degrees, your angle to be in radians as well. Okay. All right, so now we're going to go straight into the first task for today. I'm just going to open a document I prepared earlier. So as you can see here, I have actually saved some documents, and I'm going to open them up. And the first one we're going to be doing is Univariate Data 1. Okay, so here we are in my first notes page. So the first question we have here is that a survey was done on a random bunch of Instagram users, asking them about the number of Instagram followers they had. There's a list below. Create a useful histogram of this. So what we need to do is to get this data into a list and spreadsheets page. I'm just going to copy it now. And I'm just going to press Control-C, because in the CAS, which is really handy, all the shortcuts that you're used to when you're dealing with your normal computer work apply. So Control-C, Control-V for paste. And now what I'm going to do is I'm going to insert a list and spreadsheets page. A lot of what I see happening is that when someone has to insert a page, I've seen a lot of this happening. You go back to the home screen and you select one of these icons here to insert a page. What happens often is that you end up starting a new document and you wipe out everything you've done before. What I'm going to do is I'm going to go back, when that happens, I'm going to go back to current. So I'm going to press number 4 to go back to my current document. I'm going to show you how to insert a page within here. You're going to press Control and Doc. That's actually adding a page, that blue part at the top. Adds a page. I'm going to add a list and spreadsheets page. Now we're still within the same problem, because this is problem number 1, and you can see that denoted by the number 1 there. Now we're 1.2. I'm going to paste that data I copied earlier into a list and spreadsheets page. And up here, importantly, I'm going to give that data a name. So their Instagram followers I'm going to call Insta. Useful. The thing that kind of strikes me a lot is that it's not really telling me much. When I look at a graph, I want it to be useful. I want it to tell me data. Now, a lot of the values that we had in our list are kind of bunched up at the top, at the start of the x-axis there, and there's only a couple here. So this scale, linear scale, is actually not the most effective way of displaying this type of data. When data is so spread out like this, it's sometimes good to apply a log transformation. So what I'm going to do is go back to my distance sheet page. And the way you can go back is you can press Control and press the left arrow, and that takes you back to the page before. And I'm going to create another variable here called log of Insta. So now that I've given that the name, the variable is automatically stored. And what I want log of Insta to do, I'm going to put in a formula here, is I want it to take the log of base 10 of all my Instagram values. So I'm going to select log, which is here, just right here, this above the 10 to the power of x. And I'm going to give it a base 10. And I'm going to say, do that for all my Insta values. And what is a new list for me with all the logarithmic scale values. All right, so I'm going to go back to my not so useful histogram and change it. Display the log values. As you can see, a much nicer looking graph here. The scale at the bottom is a logarithmic scale, and the data has been able to then be spread out a bit more clearly. Okay. Here is a typical exam style question that I prepared earlier for you. Again, once again, this is a notes page. So I just took a photo or a screenshot, a snip of that graph. And a typical exam style question says, how many people had 3 or fewer followers? So how many of those people that were interviewed had 3 or fewer Instagram followers? Now, typical mistake that students make is that they look at this graph and they say, okay, so 3 followers, that's a number 3. I'm going to count all the number, how many people were under 3. So I'm going to go, that has a frequency here of 6. So 6 plus 5 plus 7. So that's 18 plus 1 plus 1. So that's 20, 22. Okay, so that's 22. A typical mistake is to choose B for 22, without remembering that what's happening here is actually not the number of followers, it's the log of the number of followers. So it's really important to consider that, the scale, and read the axes well. So what we're going to do here is work out what the log of base 10 of 3 would be. Now, because we're in a notes page, I can't just simply start doing my logs in here. I have to create what's called a maths box. And I'm going to do that by using a shortcut, Control M. So that puts in a box. It means I can do all my equations and all my calculations in there. And I'm going to go Control, log of base 10. I want 3 followers. And you can see there that spits out 0.477, which is quite close to 0.5. So if I look at my graph now, I'm looking for 0.5. I want my log to be 0.5, and that's here. So I have to count only the ones below that, 3 or fewer. So that's only 1, 2. The frequency is 2. That's only 2 people that had 3 or fewer followers. Now, in this question, what was we started with a list and spreadsheets page, and you had all the data, so it was quite easy to see that only 2 individuals had 3 or fewer followers. But often in an exam, all you will get is a graph, a histogram, and you'll have to decipher it. So it's really important, once again, to look at that scale. Okay. Now, here's another exam style question in a different problem. You'll note here that the problem, the tab starts with the number 2. That means it's problem 2. Now, what's important about that is that in problem number 2, all the variables that we had stored in problem number 1 are forgotten, and you kind of start on a clean slate. It shows, when I was writing this question, I chose toilet paper because I thought it was a relevant thing in today's world to discuss, but that was just to make it a bit more entertaining. Okay, so the exam style question is, the value for log base 10 of area in hectares of box will be used to produce toilet paper due to 2020 demand is 2.93. Correct 3 significant figures. What is the expected area of forest that will be used? This is a very tricky question for a lot of students, and the data shows that a lot of students get this one wrong. Number one reason is that they don't understand this relationship or the way that logarithms work. So if we know that log base 10 of the area in hectares equals 2.93, as is told in the question, what we need to know, and this is important to noting, is that 10 to the power of 2.93 equals the area in hectares. So we have to know how this equation is transposed. So to find the area in hectares, I'm just going to add another maths box. We have 10 to the power of 2.93. So the area in hectares is 851.138. Have I completed the question? Maybe, but let's go back and see if there's anything I missed. Correct to 3 significant figures. Now, don't forget to check if the question has specified if you have to round to a certain number of decimal places or significant figures. Now, what 3 significant figures means is that we only want 3 figures of significance to be in the answer. And this one has 6 figures of significance. And if you forget how to do that, how to put significant figures, there's a little cheat that I want you to, not a cheat, it's a little feature in the CAS that I want you to remember that some lady from TI-Nspire taught you, is that you can go to Documents and Document Settings, change float to the number of significant figures that you require. So I'm going to choose 3 because we want 3 significant figures. And it would automatically, as you can see there, change your answers so that they're only in 3 significant figures. That's if you can't remember how to do it yourself. Of course, you can do it yourself if you choose to. Okay. We're going to go on to the next part now. Okay, so this is a problem I created earlier, and it's about heart rates. A GP decides to collect data about the resting heart rates in beats per minute of his patients. He recorded his data in a list. What I'm going to do is I'm going to take all this data here, copy it, and for us to be able to use it in a meaningful way, we're going to have to insert a list and spreadsheets page. So again, Control Doc and add a list and spreadsheets page. It's added it one to the right of our first page, and I'm going to paste all that data in. And I'm going to give it a name because that's really important. Don't forget to give it a name so that you can use that variable name in other pages. So HR for heart rate. Okay. Now, what we want to do for this one, let's go back here. I haven't put a question in. Okay, so what I'm going to tell you to do now is we want to be able to get some summary statistics for that data. So I want to know the 5-figure summary. I want to be able to know the mean and all that. What I'm going to do is show you 3 different ways or 3 different places where you can do that. You can do that right within your list and spreadsheets page. So if I just select another cell, start again, menu, statistics, stat calculations, and we've got only one variable, which is heart rate. So we're just going to select one variable, statistics. The number of lists is 1. We don't have a frequency list. We just have the list of heart rates. We have to select the variable from this drop-down list so it knows where to look. And we select OK. What we see here that's happened is that we've had this calculation done within our list and spreadsheets page. So we've got lots of stats about this data. This X with a bar on top is mean or average, and so we know that the average heart rate recorded was 66.8. The 5-figure is found at the bottom here, starting with minimum X, quartile 1, median, Q3, quartile 3, and maximum. So that right there is your 5 summary. You can also create the 5-figure summary in a standard calculator page. I'm going to show you how to do that. We're going to add a calculator page. And we're going to go to Menu, Statistics, Stat Calculations, One Variable Statistics, choose this one, and we're going to select the variable heart rate. Okay. Spits out that same data, and here at the bottom is our 5-figure summary. I'm also going to show you how to do that in a notes page. So Control, Enter a notes page, Control Doc notes page, and in a notes page, when you start writing, it's just text at the start. Remember, when you want to do a notes page that has calculations, you have to enter a maths box. So you go Control M, and there's your maths box. All right. So what we're going to do is go to Menu, Calculations, Statistics, Stat Calculations, and One Variable Statistics. And I'm going to choose my X list. So this is the same process in all of those pages. Now, the beauty of a notes page compared to a calculator page is that, let's say I got one of my values wrong. Often happens, easy to transcribe incorrectly. So let's say my first patient didn't have a heart rate of 52. They had a heart rate of 152. Now that's pretty unrealistic, right? But I just wanted to demonstrate what happens. If I change to 152, my mean has changed in the list and spreadsheets page and has changed in the notes page. But if I go back to 1.3, which is my calculator page, my mean has not changed. So the beauty of a notes page and list and spreadsheets calculations is that they're live, which means that they're updating as we update our data. That's quite useful. So my go-to for anything, I avoid using calculator pages if I'm doing a big, long problem like this, and I stick to notes pages. Okay, so we're back into our notes page right now. I'm just going to go back and change that data so that it's not 152, that poor person. Back to healthy 152, and we're going to go back into our notes page here. Now, in the notes page, you have beautiful little features like the ability to format your text. So I can choose my text to be pink. I can then format it to be bold, whatever I like to do. Some simple formatting there, but it's useful and it helps to sort out your work. All right, so what I'm going to do now is show you another way to do the 5-figure summary. All right, so I'm going to get rid of the maths box, and I'm just going to start by doing some text. So in the 5-figure summary, I need the minimum value. I also need the Q1. I need the median. I need Q3, and I need maximum. And what I'm going to do is I'm going to put in maths boxes there and call for those variables. Now, once you've calculated the 5-figure summary, all those values are stored under this var place, which is a list of all your variables. So if I click on var, I'm going to see a lot of variables, not just my heart rate. I'm going to see statistic of minimum value. So that's what I want in the minimum. I press enter, it will give it to me. So here I'm going to add another maths box. I want now my Q1 statistic. Here I want another one. So I want here, I want my median. And oops. And there we have it. The same information as was up there, laid out this way. Now the beauty of this is that it's really self-explanatory. If you get confused by this display, you can have this display as well. And what you can do to tidy this up, because of all these weird kind of names for these variables, you can actually select all this. You can click Control A, which is select all, and go to menu and go to Maths box options and go to Maths box attributes, and you can hide the input. Let's see what that does. Now, that hides all those funny looking variables, so you get a really nice and neat display here. Okay, now let's do the outlier test. I'm just going to erase this text box and just give it a title, outlier test. Let's see if there are any outliers in our data. So we know that for the outlier test, we need the interquartile range. And I'm just going to give it a name here and then put in a maths box to calculate it. And we know that the interquartile range is given by Q3 minus Q1. So there we go. We've got our interquartile range. And now we need to know what our lower fence is. So the lowest value is Q1 minus 1.5 times my interquartile range. So I could, at this point, I could just type in that number. But what I can do is if I just go back up to this maths box, is I can actually call this calculation something. I can go interquartile range is equal to. So initiate, give it this colon equals, saves that calculation under that variable IQR. So I can call it later on. So 1.5 times IQR. And you see how the IQR has been bolded? That means it's the CAS is recognizing it as a variable that it knows. So if I go enter, it's calculated my lower fence value. And then I'm going to calculate my upper fence. Sorry, 1 second. Color on me, but that's okay. But I might take a pause there and go to the section, which is bivariate data. Just going to open up another document. Here's one I prepared earlier. Okay. Here we've got a typical exam question, bivariate data. Now this is bivariate where both variables are categorical variables. So let's have a read. 67 females and 47 males were asked about their choice of supermarket. They were asked if they preferred to shop at Coles, Woolworths or Aldi. Okay, so obviously the variables there are whether you're a female or a male, so gender is a variable, and supermarket is another variable. So what I've done here is highlighted the kind of key figures. So we've got 67 females in total, 47 males in total. So when you're asked to present the data in a two-way table, now usually you wouldn't do this on a CAS, but I just wanted to show it on a CAS screen. It's a table. You'd draw up the full table. I cheated here and did a bit of a matrix template, but this would ordinarily be in a table. So I put the total as 67 females under the female column. And we know that 5 females preferred Coles, that's given in the text, 29 females preferred Woolworths. We know that 2 males preferred Coles, 9 males preferred Woolworths. We've got 47 males in total. We have to fill out the rest of the two-way table. So obviously, if there are 67 females in total, you would quickly work out that that value there should be 33. And by subtracting the Coles and Woolworths values from 67. And here, if there are 47 males in total, 47 to subtract 9 is 38. 38 subtract 2 is 36. So there should be 36 males who prefer Aldi. Now, along here are the totals for all the people preferred Coles. So we've got 5 plus 2 is 7 there. We've got 29 plus 9 is 38 there. We've got 69. And this corner here are the totals that way and the totals that way. And if you sum it up either way, you'll find that it adds up to the same number, which is 114. So that's your two-way table done. And typically you'll have a question that requires you to create one of those. So then the next part of that question typically is present this data in a percentage two-way table. So where each rounded to 1 decimal place. So what that means is what of females prefer Coles? So what I can do, I'm just going to add a maths box here, is go, well, I know that the way to calculate percentages is I go 5 females out of the total 67 females. I have to multiply that by 100 and I can get my percentage here. Well, that's fine. And then you have to remember round it to 1 decimal place, so 7.5%. Here's a little bit of another tip for using the CAS. You can actually, rather than doing them individually one by one and working out all the percentages for all the females, rather than doing 3 separate calculations, you could do just the one calculation by using a list formula. And I'll show you what I mean. Let's put our in again. And now I want to calculate all the percentages for Coles, Woolworths, and Aldi females. So I'm going to select these curly brackets here that are good for writing in lists or sets of data. So I'm going to put in values 5, 29, separated by commas, and 33. And they're all over the total of 67. And we have to multiply them all by 100. Now that in one calculation gives us all the percentages for all the females there. But remember, in the question, it asked us to round to 1 decimal place. Now, most of us maybe can do that in our heads, but in exam situations when we're under a lot of pressure, sometimes we don't want to think that much. We want the calculator to do as much as possible for us. So what I'm going to do is go and show you how I can do this on the CAS. I'm just going to copy this here. The CAS does the rounding for us. There's a nice little command called round. And if you write the word round in front of the operation, and you must tell it to how many decimal places. So you have to put a comma at the end and put 1 decimal place. And you press enter, you'll see all those values there are given in 1 decimal place. So that's nice and handy to think about in those situations, that it can do the work for you so you don't make silly mistakes. You can either type the word round like I did, or you can find it in the catalogue here. Just press the book symbol, find under R round, and off you go. Okay, so thank you for watching. I just want to repeat that this is being recorded, and you will soon receive an email with a link to all the resources and files you've seen me use today, plus some extra revision sheets for you to practice some exam style questions. And you'll also receive a link to this webinar if you want to rewatch it, which I really encourage, so that, because I went quite quickly today, you can take it at your own pace, pause it, and really understand the concepts more deeply. Thank you again. Good luck this